Hello. This will be the very last time I make a video for a week because next week will be spring break. So you guys will get a little bit of a break from geometry and hopefully school, and you'll just be able to focus on staying healthy and getting outside and just doing whatever makes you feel just happy right now, because right now can be such a very anxious and kind of unknowing time for all of us. So I really hope that we're all able to get in a good headspace over this next break. Today I am going to offer conferences if you want to chat about geometry, or if you just want to chat about how you're doing now. I mean, I'd love to see you guys. I really miss seeing you every day, so I hope some of you will be able to join that, but if not, it's all good. So I'm just going to go over in this video some of the problems on this worksheet. I'm not going to lie, guys, I don't feel like doing all these problems, so we're not gonna. So we're only going to do about maybe half of this sheet. If you want to do all of them just for more practice, go for it, but I only am expecting you to do the problems I'm doing. So we're actually going to start with number 2, because number 2 and 1 are pretty similar. So on this front page, each of these quadrilaterals are rhombi, so we need to remember those properties of a rhombus. Some key ones to remember are that the diagonals are bisecting the opposite angles, and the diagonals are perpendicular to each other. The one that you might mix up is that the diagonals are congruent. So diagonals are not congruent in a rhombus, okay? That's only a square and a rectangle. So those are the two big things that I think we should remember. So for number 2, I'm told that BC is 28. So here's BC. And BD is 32. BD is this whole diagonal. Okay. Now I'm going to find CD. So CD is one of the outside sides that makes up the rhombus. Rhombi all have congruent sides, so all of these sides should be 28 as well. So CD is also going to be 28. Then I want to find FD. FD is this part of the yellow diagonal. So the diagonals are bisecting each other, same as true as a parallelogram. So I'm going to take half of 32 to find this FD part. So half of 32 is 16, so that means FD is 16. The next I'm going to find is EF. So if I look at EF, let me get blue. Here's EF. So the part about the diagonals are bisecting each other and forming that 90-degree angle is where we start to think about Pythagorean theorem. So if I'm finding EF, EF is like my x. I know that FD is 16. And then ED is one of those outside perimeter sides of this rhombus, so it's 28. So now I have all 3 sides, or I have two knowns and 1 unknown for this right triangle. So I'm going to take x squared plus 16 squared and set it equal to 28 squared. Okay. And the 28 is my hypotenuse because it's opposite from that right angle. It's the only side not touching that right angle. So that's why I put it in that C spot. So when I solve this, I take 16, I square it, and then I subtract that from 28 squared. So then I'm left with x squared equals 528. And then I can take the square root of both sides to get x equals 23. So that means EF is 23. Next, I'm going to find EC. EC would be this other diagonal. So again, those diagonals are bisecting each other, so that means EF and FC are the same length. So I'm going to take EF plus FC, so 23 plus 23, or 23 times 2, to get 46. Okay, for number 3, I thought I'd do 3 because 3 is a good mixture of like sides and angles, so it's a good practice for everything. So starting off, MK is 24, so that's this whole diagonal. JL, the other diagonal, which I'm going to make this a little different, is 20. And then angle MJL is 50 degrees. I'm not even going to worry about the angle yet because I just want to do the side length. So starting off, if I find NK would be half of this blue diagonal. If this entire blue diagonal is 24, I'm just going to take 24 and divide it by 2. And so that makes NK 12. And then when I find NL is kind of the same idea, but now we're dealing with that green diagonal. So I'm going to take half of 20, which is 10. And then now I'm going to find ML. So ML is one of those outside perimeter sides. And I'm going to erase the diagonals because now we know what each piece of the diagonal is, and I think that might be more helpful. So NK is 12, which makes MN also 12. Can you see that? And then NL is 10. Okay? And again, where those two diagonals meet, they're perpendicular, so there's my right angle. So when I solve for ML, I can use Pythagorean theorem again, and this time X, that side I'm missing, is going to be my hypotenuse. So I could have 10 squared plus 12 squared equals x squared. And when I take 10 squared plus 12 squared, I get 244 equals x squared. Take the square root of both sides, and you get x equals 15.6. Okay? Now the last side I'm finding is JM. JM is just another one of the outside perimeter sides of this rhombus, so it should be the same length as ML, so it's also going to be that 15.6. Okay, now we're going to deal with the angles, so I'm going to get rid of the sides. I am going to put one angle in there that I do know, or actually two angles I know. So the first one would be, these are all right angles in the middle there. And then also I have angle MJL. MJL, so this angle right here is 50 degrees. So now so the diagonals intersect to form a 90-degree angle, or the diagonals are perpendicular to each other. And then the other thing is, these diagonals are intersecting, they're not intersecting, they're bisecting the opposite angles. So that means this diagonal is bisecting this entire angle, meaning if this is 50 degrees, the angle on this side is also 50 degrees. So in total, this whole thing would be 100 if you want to look forward. But let's try to find the angles that were asked. So angle KNL, that is referring to this angle right here, which would be one of those 90-degree perpendicular angles, or right angles. And then for angle KJL, so that was the angle I was referring to just a few seconds ago, that this diagonal is bisecting. So since this side is 50, that means this angle over here is also 50. Next we have angle MLK. MLK. So angle MLK, I'm going to highlight that, would be this whole yellow angle. So before I talk about MLK, let's remember that this is also 50. So these two angles are opposite from each other. And if you remember all the way back to parallelograms have congruent opposite angles. So if we know that 50 plus 50, that's going to total up to 100 degrees for just this angle. That means this yellow angle is also going to be 100 degrees because it's the angle opposite from both of those. Okay? So this is 100. And then the measure of angle JKM. So now we're thinking about a completely different angle. This one we haven't really, we don't know much about just yet. But what we do know is that, again, this diagonal is bisecting. So whatever this green angle is, the angle right next to it has to be the same thing. But this is when you can you can look at these triangles and use the fact that all of these angles should add up to 180, or you can use the fact that this whole angle, this green plus this yellow, or not yellow, the white, they're consecutive angles to this 100-degree angle. So all of these, this green and white and yellow, they should add up to 180. Let's go the route of the triangle. I think that's a little bit easier to see. So right here let's call this angle J and K. This would be a 90-degree angle. And then I have a 50-degree angle. So I'm going to take 180 minus 90 minus 50. And I get 40 degrees. So this green angle right here should be 40 degrees. Okay? And that was coming from the triangle sum theorem, that all of these angles within this small triangle should add up to 180 degrees. So however you want to look at it is fine by me. So the next angle, JML. So JML would be the opposite angle. Let's make this one, let's go gray. Okay, and reminder that, again, I have this green angle over here. These two should be the same thing, so this green angle is also 40 degrees. So if I were to combine 40 plus 40, I get a total of 80. So since these two green angles combined are the angle that is opposite from the gray angle, those two have to be congruent, just like how we found the blue to the yellow. Okay, so since these two add up to 80, this gray angle is also going to be 80 degrees. In number 5, we're actually using some of that triangle theorem again, the sum of angles within a triangle. So starting off, I'm finding the measure of HGI. So HGI, that is this angle all the way over here. Okay? Well, right away, I noticed that the angle I've highlighted should be congruent to this angle that we're given as 4x plus 3. And if you're saying, why, Miss Jackson? Well, that's because these two angles should be alternate interior angles, and so they're always going to be congruent. So once I can figure out what x is, I could plug x in here, and then that should be the same measurement for the angle that we're trying to find. But I don't really know anything about this angle to solve for x just yet. So maybe I'm just going to have to deal with these two equations first before I can even think about finding this angle. So if I'm just looking at these two angles, I don't know anything about their measurements to say that they're equal to each other, okay? But what I do see is that they're both within one of these triangles. So this triangle is a right triangle. The right angle is formed where the diagonals meet. So right there. And both of these are pointing to angle measurements. You can tell by the degree measure right there. So I know if I take this angle plus 90 degrees, these should all add up to 180. So I'm going to take 7x minus 1 plus 4x plus 3 plus 90 degrees from that right angle equals 180. And that's from knowing that this is a triangle. And no matter what triangle it is, all the angles should add up to 180 degrees. So I'm going to combine my like terms. And so 7 plus 4, I get 11x. Then I'm going to take negative 1 plus 3 plus 90 plus 92 equals 180. I'm going to subtract 92. And 11x equals 88. Divide by 11. And x equals 8. Okay, so I have my x. Now I said that once I find x, I'm just going to plug it into this 4x plus 3 because this angle should be congruent to that red angle that we're trying to find. So 4 times 8 plus 3 gives me 35. And so the measure of angle HGI is 35 degrees. So in 7, we're given an angle measure. So angle XYZ is 36 degrees. So XYZ would be this entire angle down here. Now, when you're thinking about parallelograms, not just rhombuses in general, I said it wrong. Rhombi share all the same properties as parallelograms. So parallelograms, one of the big ones is that the consecutive angles are supplementary. So I'm actually going to think about this as this is one angle inside the parallelogram. Even though it's a rhombus, it's still considered a parallelogram. And then this green angle, if I were to find this whole green angle, those should be consecutive angles, meaning they should add up to 180. So if this one is 136, that means I should take 180 minus 136 to get 44. So this entire green angle within this rhombus is 44 degrees. Now what happens is this diagonal is bisecting this entire green angle into two equal parts. So if I take 44 and divide it by 2, I would get this would be 22 degrees and this angle right here is 22 degrees. So since I'm solving for x, I already know what this angle measure is. So I can set 10x minus 8 equal to 22. Because that's really what the actual degree measure should be. So I can figure out what x would be to get up to that 22 degrees. So I'm going to add 8. And I have 10x equals 30, divide by 10, and x equals 3. And that's it. For this one, it doesn't have many, what do I want to call them, problems, I guess, for squares. So we're going to do 10, 11, and 12. And then we're also going to talk about these kind of just very fast, like recollection type problems that deal with mainly just like definitions. So they should go by quick. So all of these are squares. So reminder that squares have all the properties of parallelograms, rhombi, and rectangles. So some ones that we didn't have before with rhombi would be that the diagonals are now congruent and all the angles that make up a square are right angles. So all 4 of these angles are right angles. As well as, again, still keeping that the diagonals are making those perpendicular right angles as well. So, oh, what is that? So starting out, I'm told that TU is 15, so that means that all of these other sides are also going to be 15. So let's see. So VU, that's one of the outside sides, so that would be 15. SU is one of the diagonals. So if I think about the diagonal, oh, I wanted the highlighter. I'm going to actually use some Pythagorean theorem because what I have is two sides and then I don't know what my hypotenuse is, because if this is my right angle, that yellow diagonal would be my C, or my hypotenuse. So I'm going to take 15 squared plus 15 squared equals x squared, or this SU side. And I get 15 squared plus 15 squared equals 450 x squared. Take the square root, and x equals 21.2. So SU is 21.2. Now I'm finding TV. TV is the other diagonal, and reminder that the diagonals in a rectangle are congruent, so TV should be the same length as SU. So TV is also 21.2. And then now I'm finding SW. So SW is just half of this diagonal. So I'm just going to take half of 21.2. So 21.2 divided by 2. And I get 10.6. Okay, in 11, we're just doing angles, and reminder that whenever you're doing problems with squares and finding their angle measurements, the only two measurements you should get are 90 degrees or 45 degrees. And that's because of all these perpendicular angles that are coming up, and then like the diagonals are bisecting those perpendicular angles. So when you cut 90 degrees in half, you're getting 45. So that's why you're only going to see 90 degrees or 45 degrees in my answers for number 11. So looking at number 1, angle EFG. EFG is one of those angles that makes up the square, so that should just be 90 degrees. Next, GDH. GDH. So this is actually one of those angles that's being bisected. Or it's formed by bisecting that 90 degrees, so this would be a 45 degree angle. Next, we have angle FEG. FEG, again, that is one of those angles that's being, that's formed by bisecting the 90 degree angle, so it's also going to be 45 degrees. And then last, angle DHG. DHG is one of those perpendicular angles, not perpendicular angles, one of those right angles formed by the perpendicular lines, the perpendicular diagonal lines, so DHG is also 90 degrees. $12 is just some more practice with the angles. Again, I'm only going to be dealing with either a 90 degree angle or a 45 degree angle, and hopefully looking at the picture you can already tell which one I'm going to be using. So if I just color in this angle right here, this is one of those angles that is formed by the diagonal bisecting that right angle within the square. So this angle measurement should equal 45 degrees. So I'm going to use that to solve for x. So 6x minus 21 equals 45. Add 21 to both sides. 6x equals 20. Oh, not 20. 66. Divide by 6. And x equals 11. All right, so for 13 through 16, I highly recommend having like your note sheet from yesterday, or yesterday, because that has probably the best notes section of every single property for all the quadrilaterals that we've talked about, and it'll be really easy to distinguish which ones you should mark off for each of these properties. So in 13, which quadrilaterals always have diagonals that are congruent? We only started talking about this when we talked about rectangles and then squares again. So we don't necessarily know that is true in parallelograms and rhombi, so you can only say that's true for rectangles and squares. In 14, which quadrilaterals always have consecutive angles that are supplementary? So this is one of those properties that we learned right away in parallelograms, so this should be true for everyone. So that would be a quick tell-all. If it's true for parallelograms, then it should be true for all, for not all of these, but all of these. Sorry, my bad. For 15, which quadrilaterals always have diagonals that are perpendicular? So this was only true for rhombi and squares. And then in 16, which quadrilaterals always have diagonals that bisect each other? Again, this was one of those rules that we talked about in the very beginning, and rectangles, rhombi, and squares all have these same properties of a parallelogram, so this should be true for all 4 of these types of quadrilaterals. All right, that's all I have, so hopefully you get 100 on this quiz today. For your attendance, it should be pretty fast and quick and easy, but yeah. I hope you guys are doing well, and I hope to see your smiling faces or hear from you before we journey into spring break. Okay?